Hey guys, this is gonna be my second video. If you saw my first video, I said I was gonna be posting on this channel, but I haven't been doing that because I got into college and got busy. But I wanted to start this series to hold myself accountable, um, because I really want a good internship, and I do have an internship lined up for this summer, but it's not the best. But I'm still really grateful for it. But I just really want a really good one for next summer, so. You can say I've already done like 52 of the 150 for neat code, but I started it earlier this semester and I just like fell off hard. So I honestly forgot like so much stuff and I'm just gonna be starting fresh. Also, the first time I think I was just memorizing solutions instead of building intuition. So I'm really gonna be focusing on that this time, and hopefully with like me explaining my thought processes for the video, um, it'll help me like practice for actual interviews where I have to explain my code and my process to the interviewer. So let's just get started with contains duplicate. Alright, so return true if any value appears twice in the rate. Okay. So for this one, you need a hash map. And what I'm thinking is that the value in the array will be the key and the number of occurrences will be the value. And uh I know there's a library, I think it was counter that does it for you, but I'm not gonna be doing that. At least for now, because in case I need to do this without any external libraries, I'm able to do it. Um yeah. So let's just get started with. Okay, so let's make a hash map. Also, my Python is not gonna be the best because I haven't done this in a while, and I've been doing a lot of like C++ recently. So we create a hash map, and for num in nums, we're gonna increment the number of occurrences, and we can use the get method, and I think it's built in the where you can assign a default value if it doesn't exist in the hash map. So hash map num equals hash map dot get the num, or if it doesn't exist, then we'll assign it to 0. We're gonna increment it, and then wait, so that should be. Let's try this. Okay, yeah. Okay, well, my runtime speed is not that good. But what I did is first I created a hash map and I counted the number of occurrences here, and then I converted the values into an array, and then I iterated through the array, and if each like occurrence, which is like I, is greater than 1, then we know there's a duplicate, so we return true. But if we iterate through the whole array and there's no duplicate, then we return false. This should be O of n, because this is O of n and this is O of n. I'm pretty sure this is also O of n. So it'd be n plus n plus n, which is just n. Yeah. Let's try to use counter so we can just speed up the future problems. So I guess we can just do hash equals nums, and then those are first. Okay, yeah. So okay, I'm curious as to how to improve the speed because it's been a while since I've done these.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve contains duplicate. This is another problem from the blind 75 list of questions we've been working on. So I like this problem because it's a good problem for beginners, but there's also multiple solutions to it that I'd like to go over in this video. So we're given an array of numbers. We want to return true if there's any value in that list of numbers that appears at least twice, but maybe it could appear 3 times or 4 times, right? Just at least twice. And we want to return false if there aren't any values that appear at least twice. Basically what that means is that every value in the array is distinct. So let's take a look at an example. We have 1, 2, 3, and then we have 1 again. So of course this has duplicates, right? So we return true, and the easiest way we would be able to detect that is by brute forcing this. So given these numbers, the first thing we do is look at the first number. It's 1. How do we know if this is a duplicate or not? Well, we'd have to compare it to every single number in the rest of the array. So that would be a big O of n time operation just to check if the first number is a duplicate or not. And then we'd have to do that for every number. Then we have to check, is the second number a duplicate? How do we know? We have to compare it to every other number. We're doing it for every brute force extract solution trying to array these we and what's but again we don't need extra in this case if it's so the entire next then sorting would look like we do go of 1. It's definitely not a bad solution, but the question is, can we do better than that? And yes, we definitely can. A second approach that will help us is sorting. What happens if we took this array and we sorted it? It would look a little bit different. It would look like this. Okay, but how does sorting help us? Well, let's think about it. If we sort the input, then any duplicates that do exist in the array, and clearly we see that 2 duplicates exist at the beginning of the array, they're going to be adjacent. So when we're trying to detect any duplicates in here, we only have to iterate through the array once. And as we do that, we're just going to be comparing 2 neighbors in the array, checking if they're duplicates. Next, we're going to shift our pointers to the next spot. Are these duplicates? Are these duplicates? Etc., until we finish the entire array. In this case, we see that these 2 adjacent values are duplicates, so we can return true. And what's the time complexity of this? Well, the one pass is just going to be big O of n, but we know that sorting does take extra memory, or not extra memory, it does take extra time complexity, and that time complexity is n log n. So that's the bottleneck in this solution. But again, we don't need extra space if you don't count the space that's used by the sorting algorithm. So in this case, we do have a slightly better solution than brute force. But actually, if we use a little bit extra memory, and it's really a trade-off, if we sacrifice space complexity, we can actually achieve better memory complexity, and let me show you how. So suppose we don't sort our input, we're given the default input.
So what's the time complexity of sort in Python? Okay, so it's n log n in Python.
But we use extra memory. We use a hash set. But what exactly is a hash set going to do for us? It's going to allow us to insert elements into the hash set in big O of 1 time. But it's also going to allow us to check. We can ask our hash map, does a certain value exist?
Okay. I completely forgot about sets, which... Okay. Yeah, I completely forgot about sets. Yeah, okay, so if we have a set, then every element in them has to be distinct. So what I'm thinking is we create a set, and if the length of that set is not equal to the original array, then we know there's going to be duplicates. So how do you create a set in Python? Like an empty set. Okay, so let's see. So create a set, and then for num in num set, is that append num if the length of hash set not equal to. Wow. Okay, add. Add for sound system. Wait, so why can't I add this? Add for set objects don't apply to an object. Int object, set object. And what? So for num and nums. Wait, what? Just gonna... Wow. Okay, so hash set. Okay, so okay. So for num and nums. Oh. Okay, I still don't know why I can't add that. Okay, so it's this thing saying okay, so if num is already in the hash set, then that means we have it, so we can return true. Otherwise we add it to the hash set, so hash set add num, and then we return false at the end, meaning there are no duplicates. Okay, I get this, but I still don't get why this doesn't work. Cause set to add, no, hash set to add. Oh yeah, so mine works too. Yeah, so I mean, if you just add to a set and the length at the end is not equal to the original array length, then we know there's duplicates. But this one's also smart where every time you add one, you check if it's already in there, then you can return true, and that would end up being more efficient. Yeah, so it's like 10 milliseconds slower, but okay, that's enough of that. Okay. So if two strings s and t, given to s and t, return true if t is an anagram of s and false otherwise. Okay, so this one, if both strings have the same number of occurrences for each letter, then so essentially if the hash map of like occurrences is the same for each string, then they're gonna be anagrams of each other. So hash map 1 equals, and this should be O of n because we're iterating twice through, which just simplifies to O of n. So hash map 1 equals that for can we use counter for this? I think we can. Let's just go ahead and use that. Oh my goodness. Okay, yeah. So that works. I guess I'll watch the solution just in case.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve the problem valid anagram, and we're actually going to be solving this a few different ways, so maybe you will learn something today. So we're given two strings s and t, and we want to return true if t is an anagram of s, or basically if both of the strings are anagrams of each other, and false if they're not anagrams. So main thing that they don't mention in this problem is what exactly is an anagram, and basically it means that, to call t an anagram of s is basically saying that using the characters of s, all of the characters, right, every single character, we can create the string t. So basically, they're made up of the exact same list of characters. So the string S, you can see that it has 3 A characters, 1 N character, 1 G character, 1 R character, and 1 M character. So it's made up of, in total, 7 characters. So that must mean that if T is an anagram of S, T has to have exactly 7 characters as well, which clearly it does have 7 characters, but are they the exact same characters as I wrote up above? Well, let's check. Okay, does it have 3 A characters? 1, 2, 3. Yep, it has 3 A characters. Does it have a single N character? Yep, it has exactly 1 N character. Does it have a G character? Yes, exactly 1 G character. Does it have an R? Exactly 1 R. It has exactly 1 M as well. So in this case, their anagrams are, both of them have an R, both of them have an A character, but one of them has a T, while the other has a C character. They're both the same length, they're both length 3, but they have one differing character, so they're not anagrams. We return false in this case. So the first solution I wanted to talk about is probably the most obvious one, and probably by just listening to me talk about anagrams, you might be able to come up with this by yourself. We just want to count the occurrences of each character in both strings, right? What's the easiest way to do that? Well, you could use an array or a hash map. That's what I'm going to use. I like hash maps. Basically, what the hash map is going to look like. So basically, we're going to have 2 hash maps, one for each string, and the key value in the hash map is going to be the character. So for example, A in string S, right? Let's use a different color. So A in string S. So how many A's are there? There's 3 A's, right? The value is going to be the count. The key is just going to be the character. We're going to do that for every single character in the string. So that's A. N has 1, G has 1, R has 1, and M also has 1. And we know that T is the exact same, right? It has 3 A's, 1 N, etc., etc., right? I could continue this. So in the end, you can see that they're the exact same hash map, right? And once we've built these hash maps, we can then go through the keys and then compare that the counts for each character are the exact same, which in this case, yes, it is. So then after that comparison, then we know that they're anagrams, then we can return true. And how exactly I'm going to do that is I'm just going to actually iterate through the keys of one of these. So in this case, for example, I'm just going to iterate through all the keys in string S. So A, N, G, and then make sure the counts, right? We want to make sure that the count of each of the characters, T has exactly 3 A's, T has exactly 1 N, T has exactly 1 G. Then so that's the big O of S. So so that's a T in the video. And the impact of both strings is exactly the same, because if they're not the same, then we can algorithm. So time they're both is based on like this. Happy around that in Python gets being done over here on the left side. But the second part in this case, that means that if this key does not exist in the hash map, then the default value that this function is going to return is 0, which is of course what we would want it to return, right? So with this line, we're just counting the occurrences of each character in string S. We can do the exact same thing with string T, just by copy pasting this and then changing everything to T. So making sure we use the T hash map and making sure pretty much counts are the same. So at character I, so the counts are the same. Actually, in this case, we'd want to make sure that the counts are not the same, because if they're not the same, then we basically know to return false immediately. Is going to be false. So you can see, basically, you can actually do exactly what I just showed you with one line of code quickly for you. And if these I did down here is that, and then we can just run that and make sure that it works, which it does, and it's actually slightly more efficient, I guess. The overall time complexity and space complexity of both of these solutions is exactly the same, just this takes more lines of code because we're actually explicitly writing out all the operations. So now what if, as a follow-up question, your interviewer asks you, how can you make a solution where we don't actually need extra memory? Can you do a solution with O of 1 memory? How would you solve that problem? It's a good question, and the solution is actually simpler than you might think. Just kind of thinking about how anagrams work, if you took all these characters and put them in a hash map where we can count the occurrences, then it's pretty easy to check if they're equal. But isn't there another way? What if we made sure that the characters show up in the exact same order every single time? What do we mean by order? Well, one possible way would be sorted order, right? Because if they really are the exact same characters, then if we put them in sorted order, then they should actually become the exact same string. Then we can literally just do an equals operation on both of the sorted strings and guarantee that they're going to be equal. But the downside is, what's the time complexity of doing sort? Well, in some cases, with bad sorting algorithms like bubble sort or something, it might be n squared, right? Good sorting algorithms can do it in n log n time, right? Worst case, big O of n log n time. But the space complexity is kind of iffy. Usually sorting algorithms, at least good ones, actually do use extra memory. They use O of n extra memory, but sometimes they don't. Sometimes they can be really optimized and actually run on constantly extra sort. If we should be the nice solution, we can just sort. The interviewer will actually want you to write out.
Yeah, I think that's fine. So if sorting it would cause a better memory complexity, but space complexity, but worse time complexity. Oh. Okay, wait. Yeah. Go to some. So, do an array of integer stuff. Hey. Return indices of the two numbers such that they add up to target. Each implies exactly one solution. Connect the same element twice. Okay. How do you do this again? Is this, can you do in? Okay. Oh, sorry. Let's just iterate through the array first. For num in nums. So there needs to be a complement. So target minus num. So if that is in the array, no, because what if it's itself? So you need a separate set where you keep track of ones that you've already seen, because if the complement happens to be itself, then it will return true, but here you cannot use the same element twice. So just make a set. Do we need a set, or can we just use an array? I think set is fine. Okay, so we need the indices. So I think here would be a hash map where we keep the key as the integer, like the num, and then the value as the index. Yeah, I need to start using like vim controls. Just add the complement. Okay, so for we keep track of the index here and the actual value here. So if the commas return, and that should be an array of the indices. So hash, no. How do we return if? So you can return anything because there has to be a solution. Okay. Oh yeah. So dang, I did this in April and now it's December. Um, yeah, so we want to make a hash map because, again, we're not allowed to use the same element twice, right? So if we just did this, if the complement is in this array, there's a chance it could be itself, right? And that would be using the same element twice. So we would have to use this. But also, we use the hash map to keep track of the indices because we have to return the indices. So we enumerate nums and then find the complement, see if we've already seen it. And because it's a pair, even if the complement does exist, so say we have like a number, right? And then this complement that does add up to be the target is behind, we'll still eventually get that same pair because we iterate through the whole array. So then we'll get to the second element, and then if we've already seen the first element, so that will be inside hash map already, which is as complement, and then we'll return the value, which is the index, and then the current index, and then we just add it to the hash map. And then this should never run because there should always be exactly one solution, but we just return like a default 0 0 just in case. Let's just watch the solution just in case.
Let's solve LeetCode 1 2-sum, the most popular LeetCode question. So we're given an input array and some target, in this case 9, and we want to find the two values in this input array that sum to 9. So in this case, it's 2 and 7. Now we want to return the indices of these two values. So the index of 2 is 0, the index of 7 is 1. So we return 0 and 1. We're guaranteed that there's exactly one solution, so we don't have to worry about not finding a solution, and we don't have to worry about multiple solutions. Now, the most intuitive way to solve this problem is basically just check every combination of two values and see if they can sum up to our target. So we start at 2, we check every combination we can make that includes 2. So we scan through the remainder of the array 1, 5, 3, and check if any of those numbers added to 2 sums to our target 4. In this case, none of them do. So next we can repeat the process. Let's check every combination including 1 that sums up to target 4. So we scan through every element that comes after it, 5 and 3, and we find that 1 added with 3 sums up to our target 4. Notice that we didn't have to check the values that came before 1 because we already checked the combination 2 and 1 when we were up over here. Remember when we checked every combination with 2? So we didn't have to repeat that work down here. We only had to check the numbers that came after 1. So the runtime of this algorithm isn't super efficient. This is basically brute force. We're going through the entire array of length n, and we're going to do that worst case n times for each number. This means that the overall worst case time complexity will be O of n squared. So can we do better? Now, the thing to notice is that for each number, for example, 1, the value we're looking for is the difference between the target and this.
Try to evaluate the complexity of this. So this is definitely going to be O of n. O of 1. I think this is O of 1. This is O of 1. So this should be O of n.
This value 1. So we're looking for 4 minus 1, which is equal to 3. So that means this is the only value we can add to 1 that'll equal the target. So we don't have to check every number. We just want to know if 3 exists. Now, the easiest way we can do this, the most efficient, is by making a hash map of every value in our input array so we can instantly check if the value 3 exists. Now let's try the same problem, except let's use a hash map this time. Now in our hash map, we're going to be mapping each value to the index of each value. So the index of 2 is 0, the index of 1 is 1, the index of 5 is 2, the index of 3 is 3. So in our hash map, we're going to be mapping the value to the index. Now we could add every value in this array into the hash map before we start iterating through it, but there's actually an easier way to do it. If we added the entire array into the hash map initially, then we would get to the value 2 first, right? We would want to check, does the difference between target 4 minus this value 2, which is equal to 2, exists in our hash map? And we would find that 2 does exist in our hash map, but we're not allowed to reuse the same one, right? Because they're both at the same index. And we this element looking for 4 minus is find a 3, so we add to the next element 5. 5 exists, have to move to the last value in the array, 3. Now the value exists and its index is 1. So now we found our two values that sum 1 half this array in one pass. Now the reason the algorithm can work in that way with just one pass is this. So let's say where they are the values that hash map, so we're guaranteed to find the solution. Now since we only have to iterate through the array one and the time component free, value to the hash map. So now let's code the solution. So we're mapping the value to the index of that value.
Okay, group anagrams. Hopefully I can get myself up to speed again pretty quickly. I mean, I feel like this first section, arrays and hashing, is like not that useful. I mean, I feel like those are just like kind of tricky. There's not really like one method like these where you can use like two pointers or sliding windows or like a stack. Where this is just like kind of tricky ways that you have to figure out the problem using like arrays or like hash maps and sets and stuff like that. So I feel like these like later ones are more important than this one. So hopefully I can finish this up fast and then review like the more important ones like two pointers or sliding window. Yeah. Let's do group anagrams. And I don't have too much time today because I have to go home because it's break. I've stayed at school like 4 days after my last final because I'm in RA and I have to take care of like move out and stuff. But today I'll be picking up my brother from the airport and I have to do that in a bit. So I still have to pack and all that. So hopefully I can get through like hopefully I can do like these two and then I think this one was premium, so I didn't do that. But I also want to set up nvim instead of like using VS Code and IntelliJ. So after these two, I'll get started with that. But oh. So given an array of strings, group the anagrams together, and return that answer in any order. So I think for this one you had to sort the strings and then group them based on that. I don't really remember how to sort in Python. Okay. So I think I can have a hash map where the key is like the group or like so like the letters that make A, E, and T will be the key and then the values will be this list. So like this will be a value, this will be a value, and this will be a value. So is that like a set? No. Okay, so I think I'm gonna iterate through all of the strings. Let's see. So I think I'm going to iterate through all the strings and then okay. I remember there's a join. Oh, okay, so I think we use sorted. Wait. Dot sort version. Okay, so we can make the hash map here. Yeah, I've been like using my mouse so much. I need to. What if I like take away my mouse? Let's put it on the charger. So we have this hash map which I can use, and then for string and so we create the sorted, which should return an array. Okay, so that can be the key. So let's see. So if it doesn't exist, okay, so if it doesn't exist, we have to add the first one, otherwise we append it. I think we can use default dict. Yeah, with the list. So okay, so hash map at temp dot add string, right? Can we just return the okay, I think we have to join, right? So I think we have to join, because this will return an array. We have to join it to make it one string, and then that will be the temp, and then return the values array, I think. Let's see if that works. Okay. List object has no attribute add. Oh, it's a hash map. Wait. Is it append for a list? because the values will be lists. List. Can we? Okay. So can we convert that into a list? Okay, yeah. So, so let me explain it now. So we create a hash map, but we initialize the values to lists, right? Because we want these lists. So we iterate through each string in the given array, and we can use sorted and then join to have like a universal way to spell each of these. So like let's see. So like for this one, it would just be like for this group, they would all sort to AET, right? So that will be the key, because for every one of the values, we're going to be sorting them. So all of them will have the key A, like spelled out AET. But then we actually, okay, so for that key, since the value is a list, then we can just append the original spelling. So for example, like AET, we will append 8, EAT, and T. And we'll keep doing that for each of these, and then we can just return the values itself, which should be an array. But I think you saw the error, like the type was like a dict list or something, but we have to convert it to an actual list. So we just cast it to a list here and then return that. Let's watch the solution.
Hey everyone, welcome back, and let's write some more neat code today. So today let's look at a good question to practice the fundamentals, group anagrams. So we're given just a list of strings and we want to group all anagrams together. So for example, we have tan and we have nat, and they are anagrams together. So in the output, we're going to group them together into one sublist. And how do we know these two are anagrams of each other? The first one is tan. The second one is nat, and you see if we swap the N and the T, then we get tan, right? And that's the same as this. So by rearranging the characters, we can get equivalent strings. So these two are equal. So another way of looking at it is two strings are anagrams of each other if we take each of them and sort them, right? So if we sort both of these, we're going to get ant, right, for both of them, because that's the sorted version. So if they're anagrams of each other, when they are sorted, they should be equal, right? So one way to group anagrams together would be to take each one of these strings in the input and then sort them. But the time complexity of that is going to be n log n, where let's just say n is the average length of each of the input strings. So that's how much it takes to sort each of the strings. And we have to do that m times, where let's say m is the length of how many, like basically how many input strings were given in the first place. So you can see that this is going to be the overall time complexity. So my question is, can we do better than this? And actually the simple solution in this case happens to be more efficient. And let me show you that solution right now. So one also condition that we're given is that each character is going to be from lowercase a to lowercase z. So at most we have 26 unique characters, right? So let's just have an array called count. So for each one of these strings, we want to count the characters from A to Z, right? How many does it have of each? So we know it has one E, one A, and it has one T. And for this one, we would see that the exact same thing is true. It has one E, one A, and one T. So if we use a data structure called a hash map in this case, and in this case, our key is going to be this over here. So this is what we can use to identify anagrams. And then our value is going to be the list of anagrams. So in this case, how many strings or which strings have this pattern of count? One E, one A, and one T. Well, we see there's one EAT, there's one T, and there's one last one, 8. So those are going to be the values. We'll have a list of them, EAT, T, and then 8, right? So we'll have 3 strings. And as you can see in the output, it's a little messy, but that's what we have here, right? So these 3 are grouped together. So we're going to use a hash map to group them together. Since we're using a hash map and all we're doing is counting the characters of each, and we know that we have a limit of 26 lowercase characters, the overall time complexity is going to be big O of M, where M is the total number of input strings that were given, times N, where N is the average length of a string, because we have to count how many of each character it has. So we're gonna have to go through every single character in a string. And since we are using count, right, or this array in our hash map, we're using it as a key in our hash map, we kind of also have to multiply this by 26 because that's what's going to be the length of our count array. But you know that this reduces anyway, so the actual time complexity is big O m times n. So now let's code it up. As you can see though, this is basically one of those problems that can be solved with a hash map very efficiently. So let's create our hash map. We'll call it result. And so remember what we're doing is we're mapping the character count of each string, and we're mapping that to the list of anagrams. So to do that, we of course have to go through every string that we're given in the input, and we want to count how many of each character it has. So we'll have initially a array. So we're gonna have 0 in it, and we're gonna have 26 zeros, right? Because one for each character. So from lowercase a all the way to lowercase z. And now we want to go through every single character in each string, and we want to count how many of each character. So we want to map, in this case, a to index 0, and we want to map z to index 25. So how can we do that? Well, we can, one way at least, is just take the ASCII value of the current character we're at, c, and then subtract the ASCII value of lowercase character a. So as you can see, lowercase a minus lowercase a is going to be 0. Lowercase z minus lowercase a is going to be 25. So we do have it correctly because, for example, let's just say a is ASCII value 80, and I don't know if this is actually correct, but it's just a random value. Then b is going to be ASCII value 81, and so on. But if we want to map this to 0, we know one way to do that is take 80 minus 80. If we want to map lowercase b to 1, we can take 81 minus 80, right? So that's basically what I'm doing here in case you haven't seen something like this before. And so we're just going to increment this by 1. We're just counting how many of each character we have. And now in our result, we want to add. So for this particular count, we want to append. We're going to append this string s. So we want to group all anagrams with this particular count together. Now, what if this count does not exist yet? Well, I'm actually going to change this dictionary to a default dictionary or a default hash map where the default value is a list. So we don't have to deal with one edge case. And also right now our count is a list, but we know in Python.
I think he's just doing this like simplification or like, what do you call it? Okay, I forgot the word, but he's just tweaking it to be a little more efficient. Like the key.
Python lists cannot be keys, so we're actually just going to change this to a tuple because tuples are non-mutable. But mainly this is Python stuff. You might not have to worry about this in other languages. And so that's actually it. So now in our dictionary, we have grouped the anagrams together, so we just can take result.values. We don't want the keys anymore. We just want to return the values, the anagrams grouped together, so we can return that, and we're actually finished. So this is the optimal m.
Okay, so okay, wait. So why you casted it to tuple again?
Lists cannot be keys, so we're actually just going to change this to a tuple. Together, so n is sorry.
That makes sense too. That's like what I had. To be honest, I don't think they would ask something like this in like a real interview. Actually, I'm not sure because I don't have that much experience, but it just seems kind of overboard to ask like just to specifically state like you cannot sort it. But I guess if you can't sort it, then you would have to do this where you get like the ordinance? Yeah, the ordinance of each character, and then have like this array. Okay, that makes sense. Let's do top k frequent elements. Oh. So how many have we done? So 5 today. Yeah. So hopefully during break I can just like bang out these problems, but given an array, nums and an integer k, return the k most frequent elements. So for this, I'm thinking another like occurrence hash map thing. So like here, 1 occurs 3 times, 2 occurs twice, and we want the 2 most frequent elements, which would be 1 and 2. So let's just get like a counter. Okay, so we have a counter, and then do you have to use like lambda expressions, or what are they called? Lambda functions. Because we want, so say we have the values, right? We get the top 2 maxes, but we need to get the corresponding key. Okay. Okay. Oh, shit. Spilled some water. It's okay, I caught it. I guess we can make an empty list and then okay, so how do we sort? I don't think you can. Yeah, so you do need a so tick with sorted items keys then. So dict sorted hash map items. So make a new dict that's sorted based on the hash map or hash map items. So the key equals lambda item. So this will sort based on the values. Okay. Do I have to set that equal to? Let's do I okay. So okay, so you do need a story, I think. see, 1 hours. Wow, I don't know why I don't remember how to do this at all. So I'm thinking we have a counter, and then this was sort of the results. Sort this based on the values. Then we get the last two, like the last k elements of the values. How do you do like a reverse loop, like for int? I guess that would make sense. Okay. I don't think that makes sense because we need to stop after k, so maybe k. Oh, okay. Oh. Oh, brother. Wait. Okay, so that works, which is not very efficient. Oh. Okay. So what I had done is that I counted the frequencies of each one, and then I sorted the dictionary based on the items, and then I just iterated from the back to get the K last keys or elements, and then I would add them to the res, and then I'll return that, but it's not very efficient. I don't know what the time complexity of this is. Let's oven. I don't know what this is. Oven. Should be O of K. Shouldn't be too bad. How do I do this? Yeah. N log n. Oh yeah, because it's sorted. I'm gonna go ahead and watch the solution video, because I think there's definitely a better way to do it.
Hey everyone, welcome back, and let's write some more neat code today. So today let's solve top k frequent elements. I really like this problem because it's pretty clever, and once you figure it out, the code is really easy to write. So we're given an input array nums and an integer k, and we want to return the k most frequent elements that appear in the array nums. We can return the answer in any order. So for example, we have this input array, 3 1s, 2 2s, and a single 3, and we want to return the 2 most frequent elements, right? So we know that the most frequent is, of course, 1. It appears 3 times, so we add a 1 to the output. The second most frequent is 2, so then we add a 2 to the output, and that's all we want. Now, if k was 3, of course, we'd add the last element. K is never going to be greater than the distinct number of elements in the input array, so that's good for us. And our input array is always going to be non-empty. So, for example, for each value, right, we're going to count how many occurrences it has. So, for example, 1 occurs 3 times, 2 occurs twice, and 3 occurs once. And then we can take this, basically this list of pairs, right? Then we can sort it in ascending order, right? So basically it's already sorted in ascending order, right? Because the most frequent is here, the second most frequent is here, the third most frequent is here, right? Now, of course, sorting it in the worst case, right? The last element. K is never going to be greater than the distinct number of elements in the input array, so that's good for us. And our input array is always going to be non-empty. So for example, for each value, right, we're going to count how many occurrences it has. So for example, 1 occurs 3 times, 2 occurs twice, and 3 occurs once. And then we can take this, basically this list of pairs, right? Then we can sort it in ascending order, right? So basically it's already sorted in ascending order, right? Because the most frequent is here, the second most frequent is here, the third most frequent is here, right? Now, of course, sorting it in the worst case, right? Basically, if every single value in here was distinct and we wanted the top k distinct values, we'd get a time complexity of n log n, right? But we don't necessarily need to sort the entire thing because we only want the top k frequent elements. So in another solution, we could actually use a max heap. So we would still do this whole operation where we count the number of occurrences of each value, and then we'd add each pair to our max heap. And the key of this max heap would, of course, be the number of occurrences, right? So the count, right? And then we'd pop from our heap exactly k times. So why is this more efficient? Well, we know popping from the heap. Well, first of all, when we initialize our heap, we're going to add this entire set, and there's a function called heapify, I think, that can do that in actually linear time, so big O of n times, so that's the good thing. And of course, we know we're only going to be popping from the heap k times. Each pop is going to take log n, and we're going to be doing that k.
So we're going to be using the key. We're going to use the number of occurrences as the key, and the actual value as the value.
K times, right? So that's going to be k times log n, right? So that's a little bit better than n log n, at least as long as k is less than n, right? But it turns out that there's actually an even better solution. There's actually a solution that can be done in O of n time, linear time. So big O of n time and big O of n memory. But we are still going to be using this exact technique where for each value, like 1, we count the number of occurrences, like 3. So this problem can actually be solved in linear time if you use the algorithm called bucket sort. So when you first think of bucket sort, this is probably what you're going to think of. The way bucket sort is usually taught is that for each value, for example, 1, we're going to take an input array, right? This is our input array. This row is the indices, the index of the array, and this is actually going to be the value. So for example, for 1, we're going to go to the index 1, and in the value, we're going to put, okay, 1 occurs exactly once. Now we're going to see a second one, we're going to say 1 occurs twice, right? Basically, we're going to go through the input array, count how many times each value occurs, and then in our input array, put that count for that index, right? Map the value to the index, and then put the count of that value. So 1 occurs 3 times, 2 occurs twice, 100 in this case occurs once. Now, this algorithm would be linear time if our input values, right, were bounded. For example, if we knew for a fact that every value was between 1 and 10, then we would know that the size of our input array is also going to be 10, right? But in this case, the values are unbounded, right? Like this could have been 1,000,000, and then the size of our input array would have been 1,000,000, even though the total input array size is only 6, right? We have 6 elements, but then that array where we actually store the bucket sort values is going to be unbounded, right? And also, we want the top k elements. This still isn't very clear of where exactly the top k elements are actually going to be. So in this case, this type of bucket sort doesn't work, but there's another way we can do it. So in this case, you can see for our array where we're going to be doing the bucket sort, the index I was using each value in the input array. For example, 1 was being mapped to index 1, right? And there we were storing the count. There's actually another tricky way that you can do it that will lead us to a linear time solution. So if we're pretty clever, this is what we're going to do. For the index, we're actually going to be mapping the counts of each value. And in the values, we're actually going to have a list of which values have exactly this particular count. For example, 100, right? We know that 100 occurs 1 time. So what we're going to do is for this position 1, we're going to say, okay, this value occurs only once. 100 occurs 1 single time. Which value, for another value in our input array 2, we see it occurs exactly twice, right? We can count that with a hash map pretty easily. And then we'll say, okay, this value occurs twice. So in the position 2, index position 2 of our array, we're going to add that value 2. 2 is the value that occurs twice. We see a last distinct value in our input array 1. We count it occurs exactly 3 times. So in this position, index 3, we're going to say, okay, there's a single value, a 1 that occurs 3 times. Now it's possible maybe we had a third 3, right? Maybe 2 occurs 3 times. In that case, we would actually have multiple values in this position, right? But in this case, we can see 1 occurs 3 times, 2 occurs twice, 100 occurs once. So they're all going to go in separate positions. And then, once we've taken every single input value and counted how many times each value occurs and then put it in the appropriate spot in this array, what are we going to do? Well, we want the top k values, right? The top k values that occur most frequently, right? So what are we going to do? We're going to start at this end of the array. We want all the values that occur 6 times. Why are we stopping at 6 though? Why don't I extend this array farther, right? 7, 8, 100, right? Why do the indices stop at 6? Notice something about our input array. Our input array is size 6, right? So that means if every single value in the input array was the exact same, the most number of times a value could occur would be exactly 6 times. So the cool thing about this new array that we're creating is it's bounded by 6, or well, technically 6 plus 1 because we do have a 0, but that's not actually necessary. But it's proportionate to the size of the input array, right? So when we're scanning from right to left or however we do it, we're only going to be doing that. We can scan through the entire thing in linear time. Now in this case, we see 6. There's no values that occur 6 times, so we can't find our top k element in that position. We'll try the same thing with 5. 5, no values occur 5 times. 4, no values occur 4 times. 3, a single value. We're going to go through every value in this array. There's only a single value in this case, but we do see a 1 occur. So to our result, we want the top k values, the top k occurring values. We are going to add a 1 to that. 1 occurs most frequently in the input array. So we add 1 to our result. We need 1 more because I think we were looking for the top 2 values. K in this case is going to be 2. So now we're going to go here. Which values occur twice? A single value, and that value is 2. So we're going to add that to our output array. So now we've gotten the top 2 values, and then we can return this array. Now, why is this linear time again? Because remember, the max size that this array could possibly be is going to be about equal to the size of the input array, right? Because we could have a value, for example, 1 could occur 6 times. In that case, we'd have 1 over here. Now, what if every single value in the input array was distinct, right? That's another extreme. What if we had 1, 2, 3, 4, 5, 6? In that case, because we could have a value, for example, 1 about equal to, because remember, and then add that to these 2 values. K in this case is going to be 2. So now we're going to go here. Which values occur twice? A single value, and that value is 2. So we're going to add that to our output array. So now we've gotten the top 2 values, and then we can return this array. Now, why is this linear time again? Because remember, the max size that this array could possibly be is going to be about equal to the size of the input array, right? Because we could have a value, for example, 1 could occur 6 times. In that case, we'd have 1 over here. Now, what if every single value in the input array was distinct, right? That's another extreme. What if we had 1, 2, 3, 4, 5, 6? In that case, this position would be empty because no values occur 6 times, no values occur 5 times, 4 times, 3 times, or 2 times. Every one of these 6 values would go in this position at index 1. Reason being, each one of these occurs exactly once. So in that case, we'll have all 6 values concentrated over here. And that's still going to be linear time because, yes, we are going to be iterating through this entire input array, which is going to be big O of n. And then we're going to add another big O of n to that, right? Big O of n plus big O of n, because we're going to have to iterate through 6 values in exactly one position. So that's still technically linear time. Now we are creating this array to help us, and we're also going to be needing a hash map to count the occurrences of each value in the input array. So the memory complexity is also going to be big O of n. With that being said, let's jump into the linear time code. It's pretty easy once you can identify this trick. So we are going to use a hash map to count the occurrences of each value. We're also, the array, the special array that's going to be the same size as the input array about is going to be called frequency. Basically, the index is going to be the frequency of an element or the count of an element, and the value is just going to be the list of values that occur that particular many number of times. So I'm going to initialize this as an empty array. The number of empty arrays that go in this is going to be about the size of our input plus 1. So now I'm just going to go through every value in nums and just count how many times it occurs. So for count of this particular n value, we're going to do 1 plus what its current count is, count.getN. Now if n doesn't already exist in our hash map or dictionary, we're just going to put a default value of 0. So this will return 0 if it doesn't exist. This is how we're going to be counting the number of times. I'm just going to go through every value. Times no values occur 5 times, 4 times, 3 times, or 2 times. Every one of these 6 values would go in this position at index 1. Reason being, each one of these occurs exactly once. So in that case, we'll have all 6 values concentrated over here. And that's still going to be linear time because, yes, we are going to be iterating through this entire input array, which is going to be big O of n. And then we're going to add another big O of n to that, right? Big O of n plus big O of n, because we're going to have to iterate through 6 values in exactly one position. So that's still...
Okay, let's go ahead and try to implement this better way. Sorry. Okay, so we have the counter, and then so we have that counter, and then we make the array, right? So we have this, the counter nums. Sorry, I wasn't paying that much attention to the video, but can I do that? See if this. So that works. So I can make a list for a length of that, and then for key value in items, not the items. So array at index value. So we're gonna append this key, right? And then so we made a counter, we have a list, we initialized the list, and then for each key value in the items, then we're gonna append at that index, which is the number of occurrences, append that value, the key. And that should be it. So then I guess we do the same thing, right? Wow. Well, k is greater than 0 for So for I in range length of nums -1, -1, -1. About that. So while it's greater than 0 for, let me do the res again. So result array, and then we can do so for k greater than 0 for, oh, I guess this would be length of the array. Will this be nested? Like, I might be tripping. I don't think I did this right. Yeah, what the hell is going on here? Oh, what? Okay. Let's go ahead.
Still technically linear time. Now we are creating this array to help us, and we're also going to be needing a hash map to count the occurrences of each value in the input array, so the memory complexity is also going to be big O of n. With that being said, let's jump into the linear time code. It's pretty easy once you can identify this trick. So we are going to use a hash map to count the occurrences of each value. It's still technically linear. The array, the special array that's going to be the same size as the input array about is going to be called frequency. Basically, the index is going to be the frequency of an element or the count of an element, and the value is just going to be the list of values that occurred that particular many number of times. So I'm going to initialize this as an empty array. The number of empty arrays that go in this is going to be about the size of our input plus 1. So now I'm just going to go through every value in nums and just count how many times it occurs.
Oh. Huh? Okay, I see what he is doing, but why does this not work? The parentheses. Okay, yeah, I'm just gonna watch.
So for count of this particular n value, we're going to do 1 plus what its current count is, count.get n. Now, if n doesn't already exist in our hash map or dictionary, we're just going to put a default value of 0. So this will return 0 if it doesn't exist. But this is how we're going to be counting the number of times each value in nums occurs. Next, we're going to be going through each value that we counted. So nc in count.items, because that's going to return the key value pair, every single key value pair that we added to our dictionary. And for every key value pair, for every number and count, values that occur that particular many number of times. So I'm going to initialize this as an empty array. The number of empty arrays that go in this is going to be about the size of our input plus 1. So now I'm just going to go through every value in nums and just count how many times it occurs. So for count of this particular n value, we're going to do 1 plus what its current count is, count.get n. Now, if n doesn't already exist in our hash map or dictionary, we're just going to put a default value of 0. So this will return 0 if it doesn't exist. But this is how we're going to be counting the number of times each value in nums occurs. Next, we're going to be going through each value that we counted. So nc in count.items, because that's going to return the key value pair, every single key value pair that we added to our dictionary. And for every key value pair, for every number and count, I want to change in the frequency array, I want to insert. So for this particular count, remember the count is what's going to be the index. So at index count, we're going to append to that list this value n. What we're saying is this value n occurs exactly c number of times. And once we've done this, we basically initialize everything we need to. So now we're going to have our result output, right? We want the top k elements. So we're going to be iterating through this array frequency in descending order, right? Because we want to start with the numbers that occur most frequently. So for I in range, length of frequency minus 1, which is the last index, and we're going to go all the way up until 0, and we're going to be going in descending order. So we're going to put a -1 as the decrementer, and we're going to go through every value. So for every, let's say, n value in frequency at this index I, because we know everything inserted in I is actually another sublist. So it could be empty or it could have some values, whatever it does. So let's say n is non-empty, then we're going to go ahead.
What did I have? This makes sense. So we have the counter, the result, the array, and then for the items, and we append like
Go ahead and take that n value and append it to our result because we're basically getting the n value that occurs most frequently. Now, when are we going to...
Oh, I see what you can do. So I think I had all this before, but we can just iterate through each index, or each list at each index. So for j in array at I, then we can append j. But k.
Going to stop. At some point, our result output is going to be the exact same size as k because we're guaranteed to have at least k values in our input array. So once that happens, if the length of result is matching exactly k, that's when we...
So if the length of then we can return res. Okay.
We can go ahead and return a result. We know this is guaranteed to execute at some point.
Is it just something with... Okay, I think I'm just doing this wrong. So for I in range, okay, this is the same thing I had before, I think. Oh, we have to check k.
So we don't have to put a return statement outside of the loop, and that is the entire code. So we could have solved this problem in decent time if we used a heap. It wouldn't be too bad. K log n. I think that's a doable solution. But with this kind of learn something or solved it as quickly as I can. Hopefully see you pretty soon. Definitely taught me something when I first solved it.
So we have this counter. Oh, I don't know why it's not working. What is it? Yeah, I knew that wasn't going to change anything, but I think that should be a -1. What the... Okay. So the counter for each one, and then I don't think any of that mattered. I feel like my code is the same thing as his. Okay, let's just... So... Okay, so we have that, and then for key value in hashmap.items. Okay.
And I know many people have been requesting problems, and I'm trying to get to. Hey everyone, welcome back, and let's write some more neat.
Okay, I have no idea. Let me just word for word just use his. Let's see. Like, I think it's the thing that he didn't check K, but at the end here, he did check if the length is equal to K. Okay. Genuinely, I have no idea what was different. Maybe I'll go back and when I publish this, hopefully I'll look through and I can like find out what the difference was, but I mean this makes sense. Like this makes sense, but okay, so you first make this hash map and then make the buckets, and then you make the counts. I have no idea what I was doing differently. Let's see if we can just use counts here. Yeah, so this works as well. But then uh, let's see if I can do the let's see if I can do like frequency equals this times. I wonder if I can do this as well. Okay, no, you can't do that. Okay, it's just like a Python thing, but okay, so you make this occurrence thing, then you you make the buckets here, and then for each key value pair, then you append the key to the index value at the the index value, and then you have this result array, and then I swear it was like should have been like this too, because it's exclusive, right? No, okay. So I guess that was also an issue. Okay, now something's different. Whoa. What did I do? Sorry, it's probably because I'm like tired right now or something, but I just feel like I'm not even changing the original code, and it's like it's not working. But so you should also you should be doing this because it's exclusive. That makes sense. Well, this exclusion makes sense. That's it for this portion. I think I have to go soon, but I think I'll record a second portion of this later, where I just do some other programming stuff and maybe some more leak code. But I mean, we'll see how I feel. Alright, guys, so I'm back with the second part. It's already 2:30 a.m. I was out for this whole day with some friends. But I just want to spend the rest of this video getting started with using nvim as an IDE. I've already started a bit, but I saw this video on Kickstart, but my nvim looks really ugly. I mean, I'm pretty sure I followed the steps that they said to do, but this just looks like terrible in my opinion. Like, it's working, but like, wow, I don't know. This guy said to like
in general, I like to
copy
open
the
this raw. I just
init.lua, which
copy.
is what I
You
did.
can use the mouse. You're about to drop the mouse forever, right? So it's kind of like giving one last kiss goodbye before you break up with the mouse. Once you have that, go back to wherever you have config nvim or .lua. In general, I like to open this raw.
Let me see if I can use auto completion. So I think it is the same. It's like auto completion, highlight, navigate, code. Yeah, it has like all this.
I just copy.
So I can copy this again into my thing. I don't think so. Like, I definitely copied and pasted this. How many lines of code does this have? 969. And that is how many I have here. Let's see.
You know, you can use the mouse. You're about to drop the mouse. Let's just see things. It gives you a nice little message to let you know and the associated configuration. So let's just see that in action. You type nvim, associate neovim. So that's WQ to save. And now the next time that you open up neovim, it'll start installing your package manager, your plugins, and the associated configuration. So let's just see that in action. You type nvim. It just says, hey, I'm installing things. It gives you a nice little message to nvim. It just created configuration. So let's just see that in action. You type nvim. It just says, hey, I'm installing things. It gives you a nice little message to let you know what's up. And then it's installing all your plugins. They've all finished installing. You quit, and now we open it up again, and you'll see, hey, I'm installing language servers. We're ready to go. Now you got a much nicer looking neovim already. They've all finished installing. You quit, and now we open, and then it's installing all your plugins. They've all finished installing. You quit, and now we open it up again, and you'll see, hey, I'm installing.
I did not see these screens at all.
Installing things. It gives you a nice little message to
I
let you
saw
know
like an
what's up.
installation screen.
And then
but
it's installing all your plugins. They've all finished installing. You quit.
what is QA? This Wi-Fi is so slow. Okay, wow.
And now we open it up again, and you'll see, hey, I'm installing language servers. We're ready to go. Now you got a much nicer looking neovim already with some real colors, a real status line, and some information going on. Let's compare the experience opening the file that we had from neovim source.
See if I can restart my config file or something.
Source tree before to what we have now. So now I've moved back to the neovim source tree just as an example of a fun project for us to navigate. You'll notice now when we open up neovim, get some nicer colors as we just mentioned, but we come with a lot more goodies now. Let's say we'd like to find that auto command file again. I type space SF to say search files, and I say,
Cannot read that. I don't know what the fuck is wrong with my Wi-Fi, but this shit is low-key pissing me off.
Like learn X and Y minutes and learn a little bit about Lua. And once you've done this in NeoVim is just run exploring something new and you don't quite know about the installation of Lazy or whatever it is the topic you're looking for, the important things for you NeoVim experience.
I'm not I'm not that used to like Unix, like the directory, so I think it's like RF, right?
And if you start typing like this, you'll see that it's not the config folder. Now on Linux and on Mac, this is simply doing no.
Okay. Okay, so that should have deleted NeoVim. Hopefully I can restart this.
LST integration, the Lua integration, telescope. Go to github.com/neovim.
This is low-key confusing. Let's see what this guy's saying.
So I am gonna do this. I am going to know you're applying line after line instead of capital to just make your any sign icons. Sign icon, shout out, copy it. Okay, so we need to do two things. One, we're gonna set the color file. One right here, very important. All right, so I guess the first thing I need to do
We're going to take a fresh install of nvim and kickstart its configuration with helpful plugins and sensible defaults. So let's quickly show what a fresh install of nvim looks like. You'll see a standard splash screen, and I can run the :explore command to browse netrw and navigate. We're going to take a fresh install of nvim and kickstart its configuration with helpful plugins and sensible defaults. So let's quickly show what a fresh install of nvim looks like. You'll see a standard splash screen, and I can run the :explore command to browse netrw and navigate the file system to bring up the index.tsx file. From there, I'll move to the file path for the home CSS module, then navigate to a file with gf. From here, let's quit. So now let's focus on kickstarting our configuration to include a reasonable set of plugins and settings. First, we'll create a .config/nvim folder in our home directory and immediately switch to that location. Then we'll take the init.lua starting point from the kickstart.nvim repository.
I swear I'm doing that. Maybe it's just my Wi-Fi or something. And I like messed it up. Try using hotspot. This is looking a lot faster. Hopefully it'll work.
Init.lua starting point from the kickstart.nvim repository. We'll click on init.lua and view the raw.
Okay.
Raw contents and copy the URL. Then curl with the JLO flags and paste the URL to download the init.lua file, curl, and view the raw contents, and copy the URL. Then curl with the JLO flags and paste the URL to download. Then curl with the JLO flags and paste the URL to download the init.lua file into our current directory. Now let's switch back to our previous directory with cd-, and launch nvim. Here we're prompted that Packer and the plugins are installing, and now we can type enter, and here the plugins are installing. When complete, you could type Q to exit the Packer output. At this point, you could restart nvim, but instead I'm going to
So this is the same as what I've seen, but this looks so ugly. Wow.
Source output. At this point, you could restart NeoVim. Q to exit the Packer output. Plugins are installing. When complete, you could type Q to exit the Packer output, and here the plugins are installing. When complete, you could type Q to exit the Packer output. At this point, when complete, you could type Q to exit the Packer output.
Is that it?
At this point, you could restart NeoVim, but instead I'm going to source $myvimrc. And you'll see that several language servers are starting to install for Rust, TypeScript, Lua, etc. Are starting to assign myvimrc. Plugins are installing, and now we can type enter, and here the plugins are installing. When complete, you could type Q to exit the Packer output. At this point, you could restart NeoVim, but instead I'm going to source $myvimrc. And you'll see that
Okay, I don't. Resourcing or config is not.
/neovim.
several language servers output. At this point, you could restart NeoVim, but instead I'm going to source $myvimrc. And you'll see that several language servers are starting to install for Rust, TypeScript, Lua.
What do I do?
Etc. And we can also see that RC. And you'll see that several language servers are $myvimrc. And you'll see that several language servers are starting to install for Rust, TypeScript, Lua, etc. And we can also see that TreeSitter is getting set up as well. We can check on the status of the language servers by typing the :mason command. And we can see that our 5 language servers are now installed.
Okay. I have no idea why it's doing that. I'm going to restart, I think. Why is my history not showing? Bruh. I tweet this shit. Bruh. Is that how you do it? Okay, yeah. Okay. This shit is just
Click on the
so
wiki, click on installing
confusing.
nvim. There's a bunch of different ways to do it. In general, I prefer building it from source, but you can also download from the releases, or, as mentioned here, install the updates, build from source, and install for yourself. That's step number 1 in the process. After you've installed, you should have some way to start.
Oh, is that why? Okay, no, it's already installed.
nvim on your system. That's probably something like typing nvim. Now, when you do that, you're going to have just this screen right here. Not a lot to go on. You don't know how to navigate or do other things inside here. I really recommend starting with Vim Tutor or heading over to the Primogen's videos learning how to use Vim. If you're interested in more ideas about that, let me know what you'd like to know. We can make some videos for it. But so what does editing files look like right now? If we just added something inside of NeoVim source tree like this, you'll see that it's not the prettiest color scheme in the hell. Not going to D configuration to an easy IDE in NeoVim is to create an nvim config folder. Now on Linux and on Mac, this is simply doing something like makedirp.config/nvim. Once you've made that folder, you can CD there, and you'll see right now that I don't have anything inside of this folder. So no, we've opened up NeoVim, nothing's there, and we don't have anything in our config. We're going to just copy one script and get started. This is where Kickstart nvim comes into play. Kickstart nvim is not a NeoVim distribution. Not that there's anything wrong with that, but Kickstart is a simple place for you to kickstart your nvim journey. It contains a very sane and sensible default setup that you can use to get started, and then that you can iterate and build on top of. You don't have to keep up to date with anything in here. You don't have to copy it. You don't have to learn a new framework. It's simply copy, paste, and let's go. All this information is documented in the README, but what you need to do to move from no config to IDE is simply take the kickstart init.lua. In general, I like to open this raw. I just copy. You know, you can use the mouse. You're about to drop the mouse. You have that. Go back to wherever you have config nvim and open up init.lua. Simply paste the file in, right, quit, so that's WQ to save. And now the next time that you open up NeoVim, it'll start installing your package manager, your plugins, and the associated configurations. So let's just see that in action. You type nvim, it just says, hey, it'll start installing your package. And now the next time that you open up NeoVim, it'll start installing your package manager, your plugins, and the associated configurations. So let's just see that in action. You type nvim, it just says, hey, I'm installing things. It gives you a nice little message to let you know what's up. And then it's installing all your plugins.
I don't know if I'm supposed to see that message or not, but I don't see it here. I see all this, and then it just becomes like blue. This color scheme is really ugly, to be honest. Like, this color scheme is just so ugly.
They've all finished installing. You quit, and now we open it up again, and you'll see, hey, I'm Atkins. They've all finished installing. You quit. And what's up? And then it's installing all your plugins. They've all finished installing. You quit, and now we open it up again, and you'll see, hey, I'm installing language servers. We're ready. You quit, and now we open it up again, and you'll see, hey, plugins. They've all finished installing. You quit, and now we open it up again.
So I don't know if I'm.
And you'll see, hey, I'm installing language servers. We're ready to go. Now you got a much nicer looking NeoVim already with some real colors, a real status line, and some.
They're installing the languages, and also I think this looks so ugly. When I just, I keep repeating that, but
Information going on. Let's compare the experience opening the file that we had from NeoVim source tree before to what we have now. So now I've moved back to the NeoVim source tree just as an example of a fun project for us to navigate. You'll notice now when we open up NeoVim, it's some nicer colors as we just mentioned, but we come with a lot more goodies now. Let's say we'd like to find that auto command file again. I type space SF to say search files, and I say, I want to look for something that has auto commanded. And sure enough, there's the name. I press enter. I want to look for something that has auto commanded it. And sure enough, there's the name. I press enter to go inside. I jump down to line 180 because that's where we were before, and I can simply start typing AP. Notice now I get completion for each of the variables that are available to me now. I start completing, and I get the different fields for each of these items. If I press GD to go to definition, I jump to the definition, which is in a different file, that uses LSB to calculate that definition. If I was wondering, where is this field used? I could press GR to look for references, and I can fuzzy find over these references. So if I wanted to find one just with curpat, I can do that. I can move up and down with Control N and Control P. I can press enter, and I immediately go to that reference. I can, in fact, do this, and I can move them to the quick fix list, and I can scroll through and work through these at my leisure if I needed to refactor them. All of those instantly come with any LSB. We can do even more than that. Explore more.
I don't know. Mine just does not look like that. That's the same as before.
Is space S8, like Lua, call the commands, configure. We've included
Okay, is that the reason why? Because I'm using the default Mac terminal? Yeah, well, I guess I'll look at finding a better terminal.
Just recently, I found the absolute best terminals for macOS. Hey guys, this is Christian, and today I want to address something that I was asked by many of you guys in the comments of my
Okay, let's see. Oh shit. I don't know why I'm not getting Wi-Fi now. Okay, I'm just gonna stick with my phone for now. Charge it.
Looks good. So we're actually going to follow it directly by running brew -- version. All right, everything looks good. So we're actually not going to be using the default Mac terminal. We're actually going to use iterm2, which I think is a lot better. So to install it, we're going to do brew install cask iterm2. So now we want to switch to iterm2, so let's close this window and then open up iterm. Alright, now that we have iterm2 up and running, we want to make sure that we have git installed. To check, you can do git -- version. I have it installed, but if you don't, you can run brew install git. After that's done, we're now going to install omyzsh, which we're going to use to configure the terminal, make it look nice, and also add some plugins. To install it, we're going to run the following command. Remember that you can find
Dang, no copy button.
this with the link in some plugins. To install it, we're going to run the following command. Remember that you can find this with the link in the description. Awesome, so things are looking a little bit nicer now. To take this a bit further, we're going to install power level 10k, which is a theme for omyzsh. To install it, we're going to run the following command. This will clone the repository from GitHub. Power level 10k. Which is a theme for omyzsh. To install it, we're going to run the following command.
Bruh.
This will clone the repository from GitHub. So now that that's installed, we want to configure it as our theme. To do this, we have to open up the .zshrc file. It's going to be located in your home folder. I'm going to open it with Vim. You can do this. You can open it with whichever editor you prefer. To open it up, I'm going to do vim ~.zshrc. That'll open up the file, and then as you can see here,
Okay, buddy.
here we have the ZSH underscore theme variable. We want to change this Robbie Russell to power level 10k slash power level 10k. We're gonna save those changes and then we're gonna quit. Cool. To apply these changes, we have to do source tilde slash dot ZSHRC, and that will open tilde slash dot ZSHRC, and that will open up the power level 10k configuration. I do want to use the Meslo Nerd font.
Huh.
That's what I've been using. It's worked out pretty well for me. I'm going to do Y for yes, and then it's going to download the font. So after the font is downloaded, you actually have to quit iTerm. So to do this, you can do Command Q, or you can go down to the dock and right click and then press quit. Because I know a lot of you might be using VS Code, I wanted to point out that once you change the font in the terminal, you'll also have to change it in the settings for VS Code's terminal by opening up the settings.json file and adding this line. So let's open up iTerm again. This is what you should be seeing now. If you don't, you can run p10k configure to open this up. It's asking if this icon looks like a diamond to make sure that the font installed correctly. It does, so I'll press the Y key, and then I'll go through these. These all look good. It asks if these icons fit between the crosses. They do, so I'll press Y. I typically go for rainbow here, so 3 for the prompt style. For the character set, I use Unicode, so I'll press 1. For the current time, I usually do 12-hour format. So I'll press 3 for the prompt style. For the character, I typically ask if these icons fit between the crosses. They do, so I'll press Y. I typically go for rainbow here, so 3 for the prompt style. For the character set, I use Unicode, so I'll press 1. For the current time, I usually do 12-hour format, so I'll press the 3 key. For prompt separators, I do angled, so 1. For prompt heads, I usually do sharp, so 1. For prompt tails, I do flat, so 1 again. For the I do I typically go for rainbow here, so 3 for the prompt style. For the character set, I use Unicode, so I'll press 1. For the current time, I usually do 12-hour format, so I'll press the 3 key. For prompt separators, I do angled, so 1. For prompt heads, I usually do sharp, so 1. For prompt tails, I do flat, so 1 again. For the prompt height, I usually do 2 lines, so I'll press the 2 key, so 1 again. For the prompt height, 1. For prompt tails, I do flat, so 1 again. For the prompt height, I usually do 2 lines, so I'll press the 2 key. And then for the prompt connection, I typically do solid, so I'll press 3. For the prompt frame, I do full, so I'll press 4 here. For the connection and frame color, I do lightest, so 1. And for the prompt spacing, I'll do 2 for sparse. I really like having the icons, so I'll press many icons with the 2 option, and I'll keep these concise, so 1. I generally don't enable the transient prompt, so N for no, and then I'll do the recommended, enable the transient prompt, so N for no, 1. I generally don't enable the transient prompt, so N for no, and then I'll do the recommended option here verbose, so 1 for no, and then I'll do the recommended, enable the transient prompt, so N for no, and then I'll do the recommended option here verbose, so 1. I want to save these changes, so I'll press the Y key. Awesome. Prompt, so N for no, and then I'll do the recommended option here verbose, so 1 for no 1. I generally don't do option, and I'll keep these concise, so 1. I generally don't enable the transient prompt, so N for no, and then I'll do the recommended option here verbose, so 1. I want to save these changes, so I'll press the Y key. Awesome. So now we have something that's looking really good. Typically, after I finish doing this, what I do is I open up the preferences to increase the font size on the terminal. We're going to go to profiles and then text, and down here, you can change the terminal font size. I usually keep it between 18 or 20. After that's done, now we want to customize the colors on the terminal. To do this, we're going to go to the Colors tab. I actually have a custom theme for my colors on the terminal. I called it Cool Night. I just wanted to call it something so I could share it with you guys. It's on GitHub, so to download it, all you have to do is run the following command. This will put it in your downloads folder. Again, you can find this in the link in the description. Let's run that. So that's going to add the file to our downloads folder, and now we can import it into iTerm to use it as our theme. So we're going to open up the preferences for iTerm. To do this, I can do Command comma, and then we'll go to profiles and then colors, and down here in color presets we're gonna hit the import, and then we're gonna go to downloads, and you'll see here coolnight.iterm colors. Let's open it up. So it should be imported now. As you can see, it's down here, Cool Night. Let's select it. Awesome. So let's close preferences, and now you can see this is the custom color theme I use. I really like it, but you can use a bunch of other themes. You can open the following website to find and install different themes. There are a lot. We're gonna add some plugins. To enhance our experience a little bit further, we're going to add some plugins. The first one is called ZSH-Auto Suggestions. To add it, we're going to run the following command. Again, you can find this in the link in the description, and then I'll press enter to clone this repo. Now that we've cloned it, we want to add it to the .zshrc file. I'm going to open it up with vim, so vim _/.zshrc, and then we're going to look for plugins. All right, as you can see here, up with vim, so vim _/.zshrc, and then we're going to look for plugins. All right, as you can see here, we have plugins down for _/.zshrc, and then we're going to look for plugins. All right, as you can see here, we have plugins down here, and we're going to add ZSH-Auto Suggestions, and then we're going to save and quit, and now we're going to reload that file, so source/.zshrc, and now we're going to have auto suggestions enabled. Let's see, if I do git, it's going to suggest the git clone command that we just ran. That's really nice about auto suggestions. It recognizes the things you've run in ran. That's really nice about auto suggestions. It recognizes the things you've run in the past, and then it suggests them to you. To apply a suggestion, you can hit the right arrow key, and then you can run that command. The next plugin we're going to add is called ZSH Syntax Highlighting. We're going to run another git clone. Let's execute that, and then after that, let's wait for that to finish. After that's done, we're going to open up the ZSHRC file again, and then we're going to
Excuse me. Oh shit.
The ZSHRC file again, and then we're going to add here CSH-syntax. Highlighting, and then we're going to save and quit, source the ZSHRC file. So what this does is that it adds syntax highlighting to the commands we run like we do with code. So if I do something like cd documents, for example, it knows that documents is a directory I want to move to, so it underlines it, and then it highlights the CD with that green. The final plugin I want to add is web search. Let's just open up the ZSHRC file, and then we're just going to add here web-search, and then we're going to write and quit. Now that we added that, let's source ZSHRC. Now that we have that enabled, we can look things up in our browser from the terminal. So if I want to look something up in Google, let's say I want to learn more about ZSH, pretty awesome. And with that, this configuration, get to subscribe to the channel to see more content. Do is run the following command. This will put it in your down. So we're going to the now, as you can see, the colors on the terminal. Here, you can change the terminal font size. I usually keep it between 18 or 20. After that's done, now we want to customize the colors on the terminal. To do this, we're going to go to the Colors tab. I actually have a custom theme for my colors on the terminal. I want to customize the ranges, so I'll press the Y key. This we're gonna go to
wonder
the
if this
colors
is, like,
tab. I
highlights,
actually have a
though.
custom theme for my colors on the terminal. I called it Cool Night. I just wanted to call it something so I could share it with you guys. It's on GitHub, so to download it, all you have to do is run the following command. This will put it in your downloads folder. Again, you can find this in the link in the description. Let's run that. So that's gonna add the file to our downloads folder, and now we can import it into iTerm. I can do command comma, and then we'll go to profiles and then colors. And down here in color presets, we're gonna hit the import, and then we're gonna go to downloads, and you'll see here coolnight.iTerm colors. Let's open it up. So it should be imported now. As you can see, it's down here. Cool Night. Let's select it. Awesome. So let's close preferences, and now you can see this is the custom color theme I use. I really like it, but you can use a bunch of other themes. You can open the following website to find and install different themes. There are a lot of them. You can then import that theme to iTerm, and then you can select it to apply to your configuration. To enhance our experience a little bit further, we're going to add some plugins. The first one is called ZSH-Auto.
Okay. Try nvim now. Oh, okay. It's not ugly, I do have to say. Nice. Okay. Okay. Yeah. Okay, I do really like that. Oh shit, sorry. Is it CD? Yeah. Okay, so now this is showing. Wait. What? I swear it is. Wait, so does that mean that it works? And then I don't know what that means. Maybe I'll just delete the files again. Okay. I feel like I'm just running around in circles. Let me get the init. Fuck. Get the raw. Copy and paste.
Simply paste the Kickstart nvim information on Linux and on Mac. This is simply doing something like CD there.
Okay, this is okay. Wait. wait. But I literally made that file. Man. Oh, was I in? Oh, fuck, I was in that directory.
And you'll see right now that I don't have anything inside of this folder. So no, we've opened up NeoVim, nothing's there, and we don't have anything in our config. We're going to just copy one script and get started. This is where Kickstart nvim comes into play. Kickstart nvim is not a NeoVim distribution. Not that there's anything wrong with that, but Kickstart is a simple place for you to kickstart your nvim journey. It contains a very sane and sensible default setup that you can use to get started, and then that you can iterate and build on top of. You don't have to keep up to date with anything in here. You don't have to copy it. You don't have to learn a new framework. It's simply copy, paste, and let's go. All this information is documented in the README, but what you need to do to move from no config to IDE is simply take the kickstart init.lua. In general, I like to open this raw. I just copy. You know, you can use the mouse. You're about to drop the mouse forever, right? So it's kind of bad. And now the plugins let you know what's up. It just says, hey, I'm installing things. It gives you a nice little message to let you know what's up. And then it's installing all your plugins. They've all finished installing. You quit, and now we open it up again, and you'll see, hey, I'm installing language servers. We're ready to...
I feel like I've done this like so many times already.
message to let you know what's up. And then it's installing all your plugins. They've all finished installing. You quit, and now we open it up again, and you'll see, hey, I'm installing language servers. We're ready to go. Now you got a much nicer looking NeoVim already with some real color servers. We're ready to go. You quit, and now we open it up again, and you'll see, hey, I'm installing language servers. We're ready to go. Now you got a much nicer looking NeoVim already with some real colors, a real status line, and some information going on. Let's compare the experience opening the file that we had from NeoVim source tree before to what we have now. So now I've moved back to the NeoVim source tree just as an example of a fun project for us to navigate.
What was I trying to do? Because I remember I had this. Oh, I think I was just looking at the Lua file, right? Yeah, I don't know. Shit is not working. Probably gonna get ready for bed soon, but Okay, that didn't work. Okay, my shit does not have battery. Uh, it's interesting. I felt like it was working before. Home director. Oh, I see. Make it a Git repo. Wow, an hour. Okay, I think that worked. Okay, I think that's all I'm gonna do for now. I'll continue learning how to set up nvim as an editor, but so far I have the kickstart right here, and I also revamped my terminal, which is nice. But yeah, I'll see y'all in the next video.